Toine is co-founder of Auroville Consulting, worked for many years on the construction in Matrimandea, and later founded and managed several community services. He's also a founding member of the Auroville Renewable Energy Group, which later evolved into several Auroville renewable energy units and activities. For 12 years, he held senior management positions in the global renewable energy sector. He also contributes to Auroville's infrastructure planning and development with a focus on energy. Just a quickie, there's a bit of a narrative developed over the last few days or weeks even that we're only 3,000 motorists here at present, and we really need to consider the needs of the 47,000 who are still to come. Toine is one of the few Aurovillians I know of, he came in the very early days, who from the very beginning of being here was thinking about the extra 47,000 in terms of laying the cables and the things like that. So I just wanted to put that in as a note. Ponnusamy has been managing electrical service at Auroville Electrical Service since 1991. Looks after all the electrical needs of Auroville and Aurovillians, including TNEB liaison work for new service connection, line extension, line deviation, transformation, upgradation work, as well as internal and external electrical work. What I remember Punu for and appreciate more than anything, just over 10 years ago we had Cyclone Toine. Those of you who were still here, or were here then, will know that Auroville was devastated. Many trees went down, windmills collapsed. Some houses were badly damaged. And of course, the electrical system was hit very, very hard indeed. What I remember was Ponnusamy and his team worked night and day for days to get the connections back. And I think we got the connections back way before almost anybody else in Tamil Nadu. So it just gives a sense of that spirit of service that I think Ponnusamy embodies.
Good afternoon, everyone. You know, today is a very special day. That every year there is one day when the distance between the sun and the earth is the minimum. And it happens to be today. Today, on the 4th of January, we have the minimum distance between the sun and the earth. So it's quite symbolic when we talk on that day about energy. I had once drafted an Auroville energy vision. And the reason that it is still called a draft after I don't know how many years is because I don't know who will approve it, who will make this draft into a permanent document. So probably it will remain a draft for all times to come. But the draft is basically saying that in Auroville, in the context of Auroville, you consume energy for a different purpose than you normally do. That we only consume energy from sustainable sources. And if we, during the process of construction, would consume non-sustainable energy, that we have to compensate for that in the future. And that finally, what really makes Auroville and the world as a whole sustainable is, of course, an integral sustainability and the transformation of matter as per Sri Aurobindo's vision. So what are the objectives of an electrical energy system or systems? You want to have uninterrupted quality electrical energy for everyone. It has to be a mix of sources and preferably distributed geographically. You have to store the energy somewhere. You have to save energy with energy conservation and efficiency measures. You have to have a demand-supply flexibility for the simple reason that the generation of renewable energy will never match exactly the demand, the instantaneous demand. Then you can do it through a system of clusters, and I'm going to explain that system in a moment. And of course, we have to create awareness among our own residents for responsible energy management. And then there is the question of energy budgeting. The strategy would be, if you want to implement those objectives, that you optimize, maximize on-site renewable energy as much as possible, on-site. You install and operate an internal grid so that you can share the renewable energy which is generated in different clusters. You would then have subgrids within that system of Auroville Township. You would have monitoring and reporting systems to know whether it is working and how it is working and how you can improve it. You would have building designs that optimize energy conservation and efficiency. as much as possible, the systems should be modular, especially in a relatively slow-growing township. You want a modular system. And then a distribution backbone to be built ahead of zone and sector development. That is going to be covered more in the second presentation on the distribution. And then, of course, we have this electricity master plan, which is going to be covered in the next presentation. Now, today, we have data pretty reliable of 2019. I'm sorry that we don't have it of 2020 and more 21, but it is not much different. Solar energy would have gone from 6% to probably 10 or 11% now. Grid energy, and then we have wind energy. You know, Auroville Foundation owns a wind turbine which is located near Coimbatore, and the energy from that is being wheeled to Auroville. But as you can see, there is still a long way to go to make it 100% renewable. Now, coming to the cost, when you invest in a solar system or even in a wind energy system or in a biomass system, you have a capital cost which is fixed, and you have very low, relatively speaking, very low maintenance cost because there's no fuel to be fed into the system. So typically today, if you would make a calculation on the cost of solar, it is probably much below 5 rupees. Small scale would be about 450 per kilowatt hours. And if you do a large scale like they do in these utility scale plants, they come even below 3 rupees a kilowatt hour. Versus the grid power that you buy from outside, which is going up typically average by 5% per annum to adjust for the inflation. So you see that delta keeps on increasing, and therefore even financially you can completely justify an investment in renewable energy. There is a worrying trend, to be very frank, in Auroville, that our per capita consumption has increased. From 1,390 kilowatt hours per person in 2012 to almost 2,400 in 2020. Now, there are various factors for that. The scheme where electricity is distributed free has definitely influenced this. There was also some suppressed demand which got fulfilled, but definitely this is not a very good trend. And we should make sure that we do not, that when we have a presentation next year, that the column is still higher, because the idea is not to consume more, but to consume less. So if we want to achieve in Auroville a 100% renewable, zero carbon energy system, how do you do that? The first thing you do is, this is an energy pyramid that we designed a couple of years back for a book called A Source Book for Asia. We designed it in Auroville Consulting, and it has been used by that book. You always have to go through these steps when you look at energy, and these steps are not necessarily done sequentially, they can be done in parallel. So the first is need versus greed. Now, need versus greed is extremely subjective, very subjective. What somebody will consider as greed, somebody else will feel it as a basic need. But I suppose that in this room, we all agree that if you enter in these 5-star hotels and the thermostat, if there is a thermostat, has been set at 80, 90 degrees where you have to wear a sweater, that's not a need. And that's not a greed either, that is just stupidity. Because you don't need 80, 90 degrees centigrade. When you come from outside 35, 36, even bringing it down to 30 or 29 already, you feel better, but it's all about relativity. So that is the first one. The second is conservation. So suppose that we all agree that we need, say, 300 lux to read. Then definitely in the daytime I can read with daylight. I don't close the curtains and then read with an artificial lamp. That is a very basic example of conservation. So conservation means maximum use of the natural resources to fulfill your basic need. Energy efficiency is about, now suppose we agree, and I think we do, that after dark we need lights. Then how can I get my 300 lux in the same example with the minimum amount of energy? That is the subject of energy efficiency. And then comes renewable energy, and then maybe for the time being we still have some fossil fuel, and hopefully in a couple of years from now that last part of the reverse pyramid will be zero. That is what we all should aim for. So this exercise is typically done. And to give you just an example, here we show, an energy, 100 units of energy, primary, doesn't matter what it is, 100 tons, 100 kilowatt hours, 100 megawatt, 100 is generated on the left, goes to all sorts of processes, heat becoming mechanical energy becoming electrical energy, transmission, distribution, and finally, we see on the right there, we see a lamp on. And now if we would replace that incandescent lamp with a CFL, not even an LED, that 100 of the first picture becomes 25. So we don't have much control over what happens on the left side, but we have a lot of control over what happens on the right side, that is the demand side. So by simple measures like that, we can make sure that in this example, 100 becomes 25, and that we reduce the dependence on fossil fuel to start with. Now we did in consulting, Auroville Consulting, we did a very interesting exercise, in fact, for the TDC last year, to look at various scenarios of per capita consumption with a growing population. And we arrived at a consensus that this green column is probably a realistic one. Now you will say, yes, but that is higher than the per capita that you showed earlier. Yes, it is higher because we believe there will be more electric mobility. We believe that we have to migrate from the LPG cooking gas bottles to some other cooking methodologies. So if you remove the fossil fuel mobility and replace it with e-mobility and you get rid of the gas bottles, 3,000 kilowatt hours per person seems to be realistic. If that is the case, we have made basically a table where we look at the estimation of megawatts needed of solar energy. So as you can see, when we have 15,000 people, we need 27 megawatt, and when we have 50,000, we need 90 megawatt of solar energy. We have done the same thing for storage. Now storage is actually the missing piece in the puzzle today. Can somebody tell me the energy which is in coal, oil, and gas? Where does that energy come from? Anyone? Any guess? Coal, oil, and gas has energy. Now you know the answer because you were in an earlier workshop. Where does that energy come from? Trees, no? From the sun. From the sun. So I would request you that from today onwards, you look at coal, oil, and gas just as three big batteries. They're not a source of energy, just like groundwater. In the morning it was explained, groundwater is not a source. The source, if at all there is a source, is rainwater. Same story with energy. The source is the sun, and coal, oil, and gas, through a photosynthesis process, took many, many years, has generated coal, oil, and gas with energy in it. So in fact, the whole energy story is about replacing those three batteries, coal, oil, and gas, with sustainable batteries. Fortunately, we don't have to discuss the source. The source still is the same, the sun. It's the only source. And you know what is nice about that source? It does generation, it does transmission, and it does distribution. When you stick your hand out of the window, you catch solar energy. You don't have to go anywhere. For coal, I have to go to a coal mine, or I have to go to a harbor where the coal is brought. For wind, I have to go to a windy area. But for sun, I don't have to go anywhere. So you can generate solar energy where you need it. You don't need to go to a centralized place and generate it. So we did these calculations. And by the way, storage, sometimes people come to me also and they say, look, Toine, all this solar energy is very nice, but why are we still connected to the grid? Why can't we just switch off the connection with TNB? He will also be jobless and be on our own. So then I usually tell these people, have you brought your checkbook? Okay, very good, please sit down. Because we made a calculation that if we go with the present growth of population, we would need by 2025, 5.4 megawatt of solar energy capacity. That will cost about 27 crores and will last 20 years, so that is doable. But for 2 days of autonomy, 2 days only, you have to make an investment of 97 crores of storage. And that you have to do every 7-8 years because storage, the batteries don't last. Now, and 2 days of autonomy is not enough because we have, for example, in that in November, we had this rainy day after rainy day. So you would need at least 5-6 days of storage. So just to give you an illustration that cutting off from the outside grid now would mean incredible investments. So what we are doing is that every financial source that we can find, we push it now into generation of energy, a little bit in storage, but the storage we will do later because we expect also the cost per kilowatt hour to come down in the coming years. But even, I would say, even if the cost of storage comes down, I would always recommend to keep connected with the public grid because you will never ever have an exact match between what you generate and what you need. So if you are connected to a wider pool, there is an offset happening at the regional, state, or even national level. So then we said, what are the cost implications? So here you see it with, let us take 15,000 people, 122 crores for solar and 51 crores for 2-hour backup. By the way, this is only 2-hour backup, not 2 days even. So just to illustrate how expensive storage is as of now. Today, a lead acid battery is costing about 10,000 rupees per kilowatt hour. Lithium ion is about 16 to 18. And we are being told that so much of research is going on that lithium ion will probably come below the 10,000 in maybe another 3, 4, 5 years. In that case, storage becomes definitely a more interesting proposition. The area requirement, that's another interesting one. There is an article which came in the Hindu this Sunday. And it is very negative about solar. Very negative. But it is negative about, not solar, if you read the article, it is negative about solar on land. In fact, he in the last paragraphs, he says, do it on rooftops. So when I first read this article, I started reading, I better cancel the presentation for the Dreamweaving. But then when I read the article, it says, no, we should do it on roofs. So we calculated what percentage of the Auroville roofs would you need for 100% solar generation with, say, 15,000, with 50,000 population. And it is 37.55. So if we would allocate about 40% of our rooftops for solar, and maybe the rest for urban agriculture, then we are done as far as the generation is concerned. So no need to convert agricultural land into solar plants. It's not required at all. And in fact, we have been promoting this rooftop solar since many, many years. I can proudly tell you that our team designed the solar energy policy of Pondicherry completely. We contributed to Tamil Nadu. We wrote something for Orissa. The Delhi policy was written 2/3 by us because we always believed that the future is rooftop solar and not these huge plants. If you take, for example, the 650 megawatt plant of the Adani company in south of Tamil Nadu, if a cloud formation passes over that system, 650 megawatt suddenly becomes maybe 100 megawatt or 50 megawatt, right? Whereas if it is distributed, a cloud over Viluppuram does not mean there is a cloud over Chennai. So you also spread your risk. Another very big advantage of distributed solar is, in the case of centralized solar, suppose the substation near that 650 megawatt of Adani has a problem. So 650 megawatt gets cut off from the grid, but the demand continues. Whereas in rooftop solar, if in a particular street the cable fails or the fuse blows, the generation stops, but also the consumption. So the advantage of distributed solar is that you match always generation with demand, whereas in centralized solar, you don't. So we have been very strong proponents of distributed rooftop solar. So what are the other things you have to look at? Flexible loads. You have to be able to meet the flexible load. You can, for example, say, why should a washing machine run in the night? It can run between 10 and 12 or 11 and 2 because there is plenty of solar energy. So those loads which do not depend on a time, you run them when there is solar energy. You don't have that choice in the case of lights. Lights you need in the night, but there are many other things that you can do when the sun is shining. We have already worked with various regulators in the country to get TOD, time of the day tariffs, even for solar, to encourage solar generators to generate the solar when the grid needs it. I have already mentioned transport, cooking, and there are so many other migrations which can happen. Cooling. There is always, air conditioning is always a very hot topic, although it is about cooling. What is our strategy for cooling? There are definitely buildings in Auroville which require cooling. I can think of a health facility, or of a place where people stay who have some, diseases and they have to be taken care of. So we have studied, centralized cooling instead of all these individual air conditioners. And it's not today's topic of this presentation, but it shows some very interesting results. We did in 2019 and 2020 and 2021, we did the first phases of what we have called the smart mini-grid. I'm happy to tell you that the Ministry of Power, Government of India, has endorsed this project with a very nice letter and is following the performance of it because they believe this is also the future for most of our cities. So how does this work? You define a cluster. So in this case, this is the town hall cluster. You see the town hall, you see the foundation office, all these buildings. And that cluster, you use the roofs, you put solar on those roofs without worrying whether the building below those panels will absorb that energy or not. Doesn't matter, there's no matching required because the surplus flows into the cluster. Normally when you do individual solar, you have to make sure that you don't produce too much because then you export it and you hardly get anything for it, or too little. Here we don't worry. We just see, okay, you see those roofs, they are fully utilized. Because we didn't have to match the capacity of the solar system with what that particular building happens to be consuming now or in the future. It is cluster-wise done. Now just imagine if you have clusters like this all over Auroville and you interconnect those clusters, which we are doing now with this almost now famous high-tension ring cable. Then what happens? The instantaneous surplus of the cluster as a whole travels over the ring to other clusters of Auroville which happen to be in deficit. And at any given time of the day, there will be clusters in surplus and there will be clusters in deficit. It will happen once in a million times that one cluster generation matches exactly the demand for maybe 1 or 2 seconds. So by interconnecting clusters with solar and storage, there's also storage in this, you get a very resilient, modular, upgradable, easy maintainable system without using any land. Only rooftops. Now this is a very interesting picture. So all these solar systems that have been installed are connected with the Auroville Electrical Service. Prasanna is there, he is monitoring all that. So he can see on his computer, minute by minute, second by second, what is happening with the help of a product which has been developed in Auroville called the Wattmon. So every system has got a Wattmon. And the Wattmons are connected to internet and the internet is connected to his computer. So he can see what's happening. Now here you see a picture of various clusters. In fact, this is transformer-wise clusters, which is easier for us to. And you see that line below here, this one. Now this is the surplus of that cluster which you just now saw, namely the town hall, generating between what time? Roughly 9:20 and 3:34, more than what it needs. And that energy of town hall, this is a town hall curve, travels to other parts of Auroville, as a result of which the whole curve of the whole of Auroville is almost coming to zero here. Right? So 1, 2, or 3 clusters in surplus compensate for 1, 2, 3 clusters in deficit, and you try to get to zero. But what would you do if you had more storage? Then, suppose, let us put it this way. Suppose there are so many clusters in surplus that the total line of the high tension connection, this one, where is it? The yard, this one. Suppose that goes below zero. Then you're exporting to the public grid. Now, if you have enough storage in place, you can then trigger storage being charged. And then what you can achieve that these morning peaks and the evening peaks can be flattened. Because when the evening peak starts, you take from the storage that you stored in the daytime, and you say do the same thing in the morning. So then this curve becomes much flatter. This is called peak shaving. Technical term is peak shaving or peak shifting. Peak shifting means that I shift this peak to the daytime. by storing. So the combination of distributed solar energy and distributed storage gives us the possibility to A, have a very resilient system, B, to, with storage combined, to shave our peaks, and eventually to come to a net zero when the whole line will be the whole day at zero or just above it. So we have concluded in our team that we can definitely achieve a sustainable energy future. Definitely also with a population of 50,000, just 40% less of the roofs and some battery storage. What we are doing now in Auroville Electrical Service, Ponnusamy and his team, they have started a new vertical. And they call it solar energy pool. So what they do is every time, so we got a grant a few years back from a very helpful company. And with that grant, we installed 200 kilowatts of solar. And then what we said was, okay, the energy that, the payment that normally would have gone to Teeny B, which is now not going to Teeny B because we're generating it ourselves, that payment goes into installing more solar and to maintain the 200 kilowatt which already is there. So this 200 already has become 300 without disturbing any cash flow of Auroville. So whatever, if suppose yesterday 100 rupees was going to Teeny B, now only 90 goes to Teeny B and the 10 goes to this project. So then you make a self-supporting, sustainable, financially also system where the solar energy keeps on growing. We have calculated that if you start with, say, 100 kilowatt in year 1, you get 3 times that in year 20. So by the time the economic life of the first batch is coming to an end, you have already double of that operating, and that's how you can grow the system very fast. So we have come to the conclusion we can have 100% renewable and zero carbon energy starting from 2025. If we can add this, I said 5.4 megawatt, we have about 500 kilowatt operating, only 10%. So we have to make a lot of effort to put another 5 megawatt of solar and storage. And then we are 100% renewable from that year onwards already. So the question is, are you ready? Oma, ready or not? Huh?
This is the end of the lecture?
Yes.
Yes.
So are there questions about this particular presentation? Yes, Dorle.
You mentioned the wind turbines and that you're wheeling that energy. How does that work? You selling the energy to somewhere and then that money is going into Auroville, or how does that work?
You see, it is a unit called Varuna. I am not part of that unit, but I know how it works. They have totally 5 wind turbines. One turbine has been transferred to, let us say, the books of the Auroville Foundation in about 7-8 years ago, and that is in wheeling mode. So wheeling mode means that the energy that that wind turbine generates is deducted in kilowatt hours from the bill of Auroville at a high tension connection. So let us give an example. Suppose you consume 1 lakh units and the wind turbine has generated 20,000 units. You get a bill for 1 lakh minus 20,000, minus some wheeling charges, but that's approximate. So that is called the wheeling. What they do with the other turbines, the other 4, of which I think 2 in Karnataka and 3 in Tamil Nadu, correct? There they sell the power to third parties, and that money they donate to Auroville for electricity. Now you could ask, why are they not wheeling more? The problem is we cannot absorb a second wind turbine. You see, absorbing in the sense, we do not consume enough with the solar that we have now because you cannot do a little bit wheeling. You either wheel or you don't wheel. I mean, you can do partial wheeling, but then they sell the surplus to the Teeny B for a ridiculously low price. So if you do wheeling, you should only do it if you can absorb, say, about 90% or so of that wind turbine generation. So today, Auroville can absorb 1 wind turbine generation and not yet 2. And of course, there is a little bit of a healthy competition going on because the more solar we put, the less room is there for. So there's a nice competition between wind and solar going on right now. But that's basically how the wheeling works.
Okay. So that means actually that the money which is coming from Varuna to pay for the electricity of the Aurovillians is just, it's not green electricity which we're getting, it's just green money. Because the green electricity has already been sold once, you can't sell the same electricity
Yeah,
twice.
so exactly. So the 4 turbines of which the energy, Prasanna, if I say anything wrong, you please correct me, because he is the one who knows all the data. The 4 you're selling, no?
Yes.
Yeah. So the 4 that they are selling the energy of, they get revenue. First, they pay maintenance. They have a maintenance contract and other charges. TNB, they have to pay the wheeling charges for the other turbine and maybe some grid charges. Yeah. And then the net amount they transfer to the Auroville Unity Fund. And the Auroville Unity Fund credits then everybody with some amount which reduces electricity bill.
No, but my point is it's green money, it's not green electricity.
It
So
is
it's basically
green, yeah. I mean, in fact, the dollar is also green, no? So, no, it's green money, if you want to call it green money.
It's not green electricity.
I mean, some of us feel, but that we don't want to debate here, but some of us feel that it would, I personally feel that money which is earned, we should also invest in more renewable energy assets, rather than everybody, getting maybe a lower electricity bill, because then you make it self-supporting. But that is a separate topic. We don't want to bring it up here. Yes, please.
I have a small question to that graph can you go back to
Yes.
the graph? It's quite interesting, like how for the 4 substations. What is that peak as? I'm just curious. What is that
Yeah,
peak
I
at
think that
450?
morning peak, I've also been wondering, is it the water heater peak or what is not
I
peak?
have a
Is it?
feeling it's Matra Mandir. Because I have a feeling that all the sprinklers go on and the lights go
It's a
on.
combination. It is some pumps are starting, some
Yeah,
people are
I think
water
pumps
heating,
and
water heaters are starting. They
Not
have,
at 4:50 in the morning. It's
what
only
time, it
Matra
depends on
Mandir.
what time. No, people may have programmed it that it starts at 4:15, so it is ready at 6 o'clock when they want to take a bath. I don't know. But my simple point is this peak is a combination of 2-3 factors. We also have a 9:30 peak. If you see, now of course not, because the solar cancels it. But earlier there would be a 9:30, 10 peak is when the offices start and the air conditioners are being put on. So in fact, we can have this live. I mean, we don't want to do it now, but we can live see right now what is happening. He has access to it. But the evening peak is also quite high, I find. I find for Auroville, the evening peak at 1920, if you see, here is a peak, which is about 300 kilowatt. I find that high. I mean, how steep it goes up. So that is, of course, you're switching on of the lights and maybe some televisions and maybe some induction stoves for cooking. So the whole idea is that you want to flatten those peaks. Because don't forget another important detail, you always have to design the capacity of the systems to be able to handle the peak. Now, if you can flatten the peak, all your transformer sizes, cable sizes, switchgear sizes, all can come down, right? So peak shaving is a very important part of the whole story.
It's interesting to see that. You should check out Matra Mandir if you can reduce that.
Which one? The sprinklers?
Yeah, I mean, it's amazing. Yeah.
Sprinklers are not very much energy intensive. Anyway.
Anyway. The other question I had was that solar, what is it? What you fund,
Pool,
solar
pool.
fund, solar pool. What are your priorities? Like, how do you decide where you're going to put the next?
Oh, it is very simple. They have made a list of all what we call the public buildings first. So Saviti Bhavan, Unity Pavilion, all buildings which are public first. And then some residential buildings have been approached. Schools, everywhere. The priority right now is to put it in the area which is connected to the high tension, our internal grid, for a simple reason, because then it can migrate to other parts of Auroville. If you put it on a low tension individual TNB connection, the surplus goes to TNB. And the compensation for that is very, very low. So the priority is to put the new solar systems within the city area where we are all connected to one connection, which is just behind there. 86, you can see it here, 86. So that it stays within the fence, so to say. A little bit spillover is there. On a few days in the month, you are spilling over to TNB, right? Or you are trimming it?
20 to 30 units.
20 to 30 units, that's symbolic. So we have a bit of a spillover. But then, of course, when the spillover threatens to become higher, then you put storage. And then instead of spilling it over into the public grid, you spill it over in your own.
We also
grid.
start connecting other loads which are not connected to this.
Now, increasing it, yes.
Yeah. And last question, Ponnusamy, are you going to present how you're phasing out the overhead tension lines from Auroville? Like, you want to change the substations and are you
That's
going
coming
to
in the
present?
next, next presentation.
Because that thinking about also electromagnetic fields,
Yes.
it's good to reduce that by putting in the ground.
Yes.
And we also don't lose so much land.
Yeah.
Because always there's trees and cutting and pruning, and it's a lot of maintenance.
Next presentation, we will show you how this whole overhead jungle has been replaced by an underground system.
You'll be so happy to see that.
Yes, I'm waiting for it.
We have already said this among us a few times. There are many similarities between the energy and the water scenario in terms of strategy, in terms of source, in terms of storage. I mean, the principles and the mechanisms are very much similar. What is a bit worrying is that increase in consumption. Because I remember a few years ago there was a presentation where it was said it will naturally come down. And I really trusted that that would happen. But actually, when I see this graph, it's a bit worrisome. Why? Because if I make a parallel with the water, the moment we will achieve the water security, actually the water abundance, if we put in place certain measure, and then we want to be a beacon for others, then we should always remember that graph should never go increasingly high, but it should be with consciousness of consumption, an example for the others.
Yeah.
So it would be very much interesting, in my point of view, but I think also in the collective, to understand if it's possible, what are the mechanisms which are implying that higher consumption. Thank you.
Yeah. So no, I am fully with you, and you have seen it. It's it's almost a doubling from 2012, and definitely, I mean, the scheme of free electricity has contributed to this 100%. What happened is people started purchasing air conditioners, which were not always the most efficient ones, right? So that whole scheme we also may have one day to look into. What are the measures? What Auroville Electrical Service already does, if they see a sudden increase in somebody's house or thing, they give them an alert. And in fact, they even go there to find out what's happening. Have they maybe the air conditioner on with the window open or stuff like that? But what I believe, when we worked with Lavinier de Auroville on Sector 1 and Sector 2, when they prepared the DDP, we gave them inputs for an energy strategy, where we said you should have an energy budget. Like you have a financial budget. How many kilowatt hours per person on average do we want to budget for? It is not that everyone will consume the same amount of energy, but on average. So if you say, for example, that including, e-mobility and e-cooking, suppose it comes down to 3,000, because e-cooking is a big ticket item. We never talk about those LPG bottles, but if you start replacing them also, suppose it turns out to be 3,000. I'm not saying it is, but suppose. Then that becomes your energy budget. And then we have to inform the community, listen, we are going to generate a population multiplied by 3,000, not 1 kilowatt hour more, right? And then we have to do load shedding if it goes above. It has to be a collective awareness campaign. You can get equipment which is super efficient. And sometimes people are hesitate to do it, because the upfront capital cost is sometimes a bit more. But in most cases, you can demonstrate within 2-3 years that extra capital cost is already paid back. So more awareness have to be done. And as far as the DDPs are concerned, my recommendation would be to include in the DDPs an energy strategy and an energy budget. And then maybe the target can be achieved. This is not a good trend at all, this increasing.
So thank you, Toine, for that presentation full of numbers. One thought is that, is it possible to also think of distributed production of power, like not totally put all our eggs in solar, but when solar goes down, can we also think of some push button technologies like biomass generation, biogas generation?
Yes.
So they can dampen the peak.
In the more detailed document, of which this is a summary, we have written that there should be diversification of sources as well. Solar is an easy one to do because you have rooftop, but definitely biomass should be another one. We have even looked at micro wind for Auroville. But it is a border case because you have a bit of wind typically in the evenings, that sea breeze, but it does not make a case yet to do in a big way micro wind. There is now an American company that is in touch with one of our colleagues who says, I will at my cost demonstrate that it will work. So if that person is still up to it, we will put a few micro wind turbines and show. But definitely it has to be diversified. You can't put all your eggs in one basket, even if that basket is solar. Yes.
Okay, thank you, Toine, for the presentation. I told you I have very little knowledge of the meticulous data of electricity, but the concept of clustering is honestly very sound to me, because in the area of bioclimatic design, this is where the world is going today. We recognize that thinking of building by building doesn't work much. We find that some buildings in one cluster generate heat while other buildings need heat, and then becomes how. And I remember some professor was telling, imagine all of this heat coming from the metro stations in London. There is a way to use it. So this is very sound to me. So now the main question is, now you have 22 architects who are working on Dreamweaving for the Crown. How this can be clustered? Do you see it as one cluster, or you see it as there's a specific range of distance that has to be respected? And then if you are giving recommendations, what kind of, the architects are working on the level of geometry and form, there is any recommendation that they could think, this is what we call integrative design, that the engineers and the architects are since day one interacting. Are there any recommendations that you can, in which they can implement? Yeah.
No, very good. So you will see in the next presentation that when the electricity master plan was prepared, we instructed the consultant, the development consultants in Calcutta, we don't want any transformer size above 250 kVA. See, there is always a trend to put big transformers and fewer of them. We said, no, we want to penetrate into the urban fabric with high tension more to have long-term benefit of reduced energy losses and voltage drops. And they accepted that. So one way to do it is at transformer level. So a transformer is a cluster. You could also say a transformer have 3 clusters and then integrate at switchboard level. The nice thing about it is you can be as flexible as you want to be. You can have a small cluster, big cluster, medium cluster. You can have one transformer as one cluster. You can have 2 transformers as a cluster. It's just a question of basic engineering. So the answer is the detailed development planners can just inform the technical team how they want to do the planning, and it can adapt to it. It can be, for example, in this case, I think it is on one transformer, am I correct? Yeah. So in this case, it is cluster-wise, transformer-wise in the town hall. But you could, if you have a larger area where, one transformer for the time being, till the density improves, is having long cable lengths, you could say, okay, I put a cluster here and I put a cluster there. The idea is that, you see, for years together, in workshops like this, there used to be always 2 camps. So one camp used to say centralized, and the other camp would say decentralized. And they would also sit more or less like this, one on the left and one on the right. So we have thrown both of these words out of the window long ago. It is neither centralized nor it is decentralized. It is distributed but connected. Distributed but connected. And the same thing with water. You would harvest the water maybe in many, many points, but you want to connect. So we don't talk anymore in terms of centralized versus decentralized, distributed and connected. Okay, we can do this. See, basically, in the early days of Auroville, we were even less dense than we are today. Very low density, a building here, a building there, a community here, a community there. And there was never any money for infrastructure. So what was the simple thing to do? You asked the TNEB to bring an overhead line. Those overhead lines for certain categories would be free also. If you had more than 2 connections, the overhead line would come for free. So you take, for example, Sincerity Community, there were 4 houses, you apply for 3 connections and they bring all the poles free of cost. We knew, we both knew that this cannot last very long. This has to stop because it became a spaghetti. Or what would be another, in your menu, what would be the equivalent to a spaghetti? in Egypt. What is the equivalent to?
Spaghetti.
Spaghetti, also spaghetti. So it became spaghetti without a very good sauce, by the way. So we said there was an organic, unplanned growth. Just, and quite frankly, the architects also, they said, I don't want to hear about it. Just give me a water connection. I don't care from where. Give me electrical connection. I don't care from where. And give me a telephone connection. I don't care from where. That was the system in those days.
Not only that, they were not planning at all.
No, the plan was for a
The plan
particular
was for the
building.
particular building only, and then once the building is completed, they will come to me for getting a connection. They will not even tell us that the building is going to come in this area, and you have to plan for a overhead line or a TNB connection. Totally, the building will be totally completed. Then they will come for an electric connection. So we have to apply and then see with the TNB how to bring the overhead line to that location.
So it became something like this. I mean, this is still a mild version. A complete web of lines going, high tension line, low tension lines. There were also earlier telephone lines. The BSNL was having overhead lines for every telephone, 2 GA wires. So if you have 20 telephone lines, you have 40 wires. It was a complete mess. The problem with overhead lines also is, let us say there is a overhead line going from here to there to an Auroville building. And a private party who owns the land just 200 meters away says, hey, the line has come pretty close now I also apply. Even if tomorrow we would decide to get rid of the overhead lines, because of that one private party, you can't remove it.
The entire transformer cannot be removed.
Transformer, high tension line cannot be removed for just one party. So both of us saw this coming quite some time ago. We said, this is going in the wrong direction completely. We have to do something about it. This was what happened after Thane. Already was mentioned in the introduction. 150 poles came down, 3 transformer structures, and we were in the field for 3 weeks.
3 weeks.
To put it. This happened with overhead lines. No, they just snapped like twigs. We got help from a lot of people. In fact, a friend of mine who was working in Kalpakam, he sent 2 JCBs, and we got equipment from so many people. We worked with the TNB closely together. We did also some work outside of Auroville with TNB to get the whole region up.
We even got the chairman of Tamil Nadu Electricity Board to help us.
Yes, correct.
He came here, yes.
He came here. So that vision I've already shared with you, so we don't have to repeat. A quick reminder for, especially for Omar, that in electricity, you say power, P, is voltage multiplied by current. P is V into I. So a particular quantity of electricity you can transfer from A to B either with a high voltage or a low current, or a high current and a low voltage. So what is typically done is that when you transport over a long distance, which is called transmission, you have it at a higher voltage and a lower current, because high current means big conductors, and the losses in a cable or a line are I square, current squared, multiplied by the resistance. So if you have double the current, you have 4 times the losses. So normally when you transport over a longer distance, you like to have the voltage to be high. And that's why transmission lines are 230 kilovolts, 110, 400. Then you have 3311 distribution, and finally you have what you get in your plug, 230 volts. So that's why now these are the standard voltages normally used in India, which are 630, 400, 230, 110. HT is 66, 33, 11. And then the LT is, of course, 230 single phase and 415 three phase. The last one is what you are dealing with when you are in your house. The problem that we have in this particular area is that there is a voltage which is not standard, used by the TNB, which is 22,000 volts, 22 kV.
Non-standard voltage.
Non-standard. Pondicherry also had it. They have replaced most of it with 11. Jipma still has it. Mutialpet is in the process of being changed. So when you have a 22 kilovolt system, when you purchase a 22 kilovolt switch, you are actually purchasing a 33 kilovolt switch with a 22 kilovolt label on it. So you're paying too much, and it is much bigger. So we had wanted for the last 20 years plus to get the whole system changed to 11 kilovolt from 22. At one point in 2009, the TNB also realized that they would like to do it not just for Auroville, but for the whole area. So they were telling us, you give us 2 acres of land, and we will put a 110 by 11 kilovolt substation, and everyone in this area will remove the 22 and put 11.
So the transformer cost and the line cost the switchboard cost, all that will be reduced to not even half, or less.
Unfortunately, Auroville, for some internal process reasons, could not agree on to give those 2 acres of land, so that idea was dropped. They came back with another proposal to have a different type of land. It's a long story. Finally, 2-3 years ago, when again we told them, look, we want 11 kV, they said, listen, we have come to the conclusion that in any case we want to build a substation there because the Irumbai substation is getting heavily overloaded. So if you give us 2 acres of land now, we will build a 110 by 22 by 11. So in other words, there will be a 110 incomer. There will be about 4 feeders, 22 for the villages around. And we can give you an 11 kV feeder provided you pay for it. They were no longer interested to convert the whole area into 11 because they could not.
They could not manage
the cost of all the changing all the transformers. As you know, TNB is in a very bad financial position. So the 2 acres was given, leased out to them for near 8-inch Javadi. They have started the work. So the idea is basically they built a substation, 110 incoming, 22 kV, 4 feeders out for village loads and 1 feeder for us. The work has been stopped because some landowners are objecting to the towers coming into their land. Most of the towers come on Auroville land, but a few come on private land, so that dispute is being taken care of or being discussed now, negotiated. So here you can see why, also from a cost perspective, the migration to 11 kV is very interesting. I mean, you take a transformer, same 250 kVA, 11 kV would cost you 8 lakhs and 22 kV cost you 14. And same thing for switchgear and cables. So there is a very strong case to go for 11 kilovolts. So we decided then, we recommended to the TDC, listen guys, whether you have your DDPs ready or not, we need an electricity plan. We cannot keep giving ad hoc connections, mix of overhead lines and cables going here and there. So a tender was written for doing this plan, and it was won by a company in Calcutta called Development Consultants Limited. We were quite happy that they won the tender because the chairman, the late chairman, Mr. Dutt, was also a devotee and used to come to Matamildi and the ashram quite often. And they did it at a very reasonable price. So they prepared a plan with us together, all the way till 50,000 people, but designed in such a way that you can implement it in small steps. So it has an HT plan, it has an LT plan, it has a road and street lighting plan. It has got phasing. The phasing is, of course, taken from the master plan of Auroville, 5, 15, 25, and 50. It comes to basically a distribution capacity of almost 1 kilowatt per person. Now you'll be wondering, is that not low? Yeah, that is low, but it is. You always have to look at diversity factors. It's not that everyone has all the load on all the time. So you come with a capacity needed of, say, almost 1 kilowatt per person. So 11 kV will be the distribution voltage, not 22. Now the question was, how do we get now 11? At that time we were wondering, how do we get? One option was you convert, you take a 22 kV incomer and you step it down to 11. Then all the transformer losses will come to Auroville's account. And in any case, once we cross 5 megawatt, we have to again migrate to 110 kilovolts. Then you become a 110 kV consumer. So we looked at various options. I won't bother you with the details, but basically, let me go straight away to that conclusion. This was plan 1. So we have 22. We keep the 22 of TNB till they change and we step it down ourselves, was option 1. Option 2 was we have dual ratio transformers. So they can be switched over from 22 to 11 once the 11 comes. And we have done initially this particular option. The first 4 or 5 transformers are this. But then we came ourselves, after the master plan was already completed, with an option 3. Which was that we heard several times that TNB was interested in building a substation for other reasons than Auroville also. So we said, listen, if we can engage with them, then maybe we can accelerate the 11 kV, and that's what is happening now with the new substation. Ultimately, by the way, once we cross about 5 megawatt, I think it's 5 megawatt, the limit for, then we have to become a 110 consumer, and then we can build our own 110 by 11 nice indoor substation, very compact. That is, of course, to be done at some point of time also. We briefed the DCL. We had a very, by the way, we had a very nice constructive interaction. It was not a typical consultant-client relationship. In fact, they wrote a very nice letter when they were done that they picked up a lot of nice ideas from Auroville, which they are implementing later. For example, this idea of 250 kVA as a limit. Initially, they said, no, why 250? 500 kVA minimum, 750 kVA. So we convinced them that initially the capital cost is a bit higher. Because if I put 2 transformers of 250 rather than 1 of 500, I have an initial capital cost which is a bit higher. But we could convince them with simple calculations that the reduction in energy losses, etc., would pay that back in a couple of years. So they got completely convinced. Have you installed any transformers beyond 250 kVA?
No.
Okay, so I just want to check before I commit. So electrical service is not going beyond 250 kVA. So if the load is 500, it will become 2 times 250, 1 here and 1 there. So you bring the high tension closer to the load. And if you do that, you reduce the energy losses tremendously.
And the cable size also, we have not gone more than 150.
150. 185 or 150?
180.
185. So basically, the main features of that electrical plan are there is a high tension ring. That high tension ring will be 11 kilovolt. Now, for the time being, it is 22. It has a total cross section of 600 square millimeter aluminium, but we are doing it in 2 steps. Right now, one cable is almost laid of 300 square mm on one side of the crown, and the other one will be laid later. Now, why do we do that? First of all, it is very difficult to justify financially that you invest now for 50,000 people in a ring. Second thing is, having 2 cables instead of 1 gives you more resilience. If tomorrow one cable would fail, you can do with a bit of load shedding, you can still feed the essential loads in Auroville. So finally, if this is the crown, there will be one high tension cable of 300 square mm on this side and one on that side. It is now a 22 kV cable, but you can operate, of course, a 22 kV cable at 11 kV, not the other way around. So basically, how would it work? You have a ring, and then you go along the radials, you penetrate into the urban fabric. I mean, these are just illustrative only. I don't think it will be literally like this. As the town grows, so that is the nice thing about it, it's very modular. So if suppose the TDC decides to focus on Sector 1 and Sector 2 of the residential zone, which is actually designed for 5,000 people, where only 800 are staying, then that radial will be done first, along with the spur lines going from the radial. So you can keep on building on it, but of course the ring on which you build is like the foundation of a building. That has to be designed straight away now for half and later for the full when the second cable is laid. So you keep on doing that. And then finally, we always have a moment of tension, whether it fits or not. Does it fit? Ah, my God, what a relief. So this is what you basically do. And you connect it, of course, to the outside world, at least at 1 or 2 places. Again, for the reason which I gave earlier, that you don't want to become an island with enormous amount of storage. Now, maybe this is basically the summary. So 2 connections to the outside world. Finally, an interconnection at 110 kV level when we cross a certain population. Transformers are all indoor, LT underground cables. So no more overhead lines, all gone. Energy efficient systems, because of this design, we get a very low I2R losses. The grid is fed from Auroville grid connected renewable energy systems, as I explained in the earlier presentation. They can export to each other and import from each other, the buildings and the clusters. All the meters that electrical service installs are all bidirectional meters, for those who know what a bidirectional meter is. So they are solar ready. Yes. And there is, by the way, no cost difference between a so-called unidirectional and a bidirectional meter. It is only the manufacturers who want you to believe, but they understand that we understand that there is no difference. So we get bidirectional meters with 4-quadrant metering at the same cost as people pay for a normal unidirectional meter. They do energy metering audits online. Already we have, in March 21, we have 400 kilowatt of solar up and running. Off-grid in the green belt, by the way, I forgot completely to mention that. Sorry for that. In the green belt, there are a lot of standalone systems. I think you must be on standalone, Alan. So that means not grid connected, battery bank, solar, and the battery has to take you through. Did you have any problem with that 1 week of rain or not? No. So it means you have a good battery bank, quite a big one, yeah. And Mona, conversion of TDB overhead lines to underground. How many service connections have you cancelled?
We have cancelled about 565 service connections.
Cancelled means overhead line connections, all taken out and all merged into one high tension connection.
Whole of Bharat Niwas area has been completely removed. Whole of Matra Mandir, residential zone, up to admin area. We have completely removed all the overhead lines, all the transformers of TNEB. We have our own underground cable and our own distribution transformers in 5 different locations.
Yeah.
Our own transformers, which are giving supply by AC number 86.
The connection is right there. So it is now a 22 kV connection, and from there it distributes through the ring to the whole of Auroville. So what has been done till now, the municipal energy plan and future installations was done in 2003. The code of practice has been written and is being updated every 2 years. It's a code of practice that we have ourselves designed, which is of course taking into account the statutory provisions, but we go a bit beyond it. We do a bit better, if I may use that word. And then the electrical master plan. So what are the clusters already included?
Matra Mandir, we have included Bharat Niwas, Visitor Center, whole of nursery, we have Centerfield area, language lab, and Bharat Niwas I have mentioned. The admin zone completely we have covered with the new transformers. And the residential zone we have covered almost up to Certitude. Few more service connections is left to be connected in Certitude area. All the rest is connected to one HD service connection.
So the advantage of doing this is not only that we got rid of the overhead lines, but as I mentioned in the earlier presentation, we can now transport energy, solar energy, renewable energy from one cluster to the other cluster over our own network.
Of course, the maintenance work is also very minimum now. We don't have much maintenance. Like we used to send 3 teams at a time to attend the overhead line fault and all. Now we have got only 1 team to attend the underground cable system.
So this is what is planned for 21, 22, 22, 23. The TNEB substation that's fully in their control. We have nothing to do with it. We hope that they can overcome this problem. Then we have to build a receiving station next to it to receive the 11 kV from them. And then through one of the radials, it has to be taken to the ring. So clusters that will be included in 21, 22, and 22, 23 are?
Visitor Center.
Yeah.
And then we have industrial zone.
Yeah.
Mona, your area. And cultural zone.
You are still having overhead lines, no?
Yes.
Yeah.
Still in overhead.
Yeah, this famous topic of the right of way, you see, I think Toby is going to give a presentation in one of the sessions on the whole infrastructure, so I don't want to go deep into it. But it is so important that these underground services are laid in the right place from the beginning. It is almost impossible, and if it is possible, extremely expensive, to tell, for example, after a high tension cable is laid, to say, sorry, actually, it should have been laid there. It's just impossible. So that's why this right of way clearing is not just to clear it, but to also physically see, okay, here it is coming, because there could even be a genuine error of a new surveyor coming to the site. And he says, yes, you can build a storeroom here. He checks and yeah, go ahead. And the person builds the storeroom, and the next surveyor who comes, who knows his job better, says, no, this was supposed to be a road. So even to avoid genuine errors, if the right of ways are cleared and on both sides the infrastructure is properly installed, what we have done, by the way, we have put for every service a sub-corridor. So if the corridor is, say, this much, there is high tension at 1.20 meters, low tension at 70 centimeters, water at 50, and they also have a horizontal clearance. Sometimes people ask me, but why are you doing all this? If you look at Pondicherry and Aero Street, they manage all these cables in just this much of pavement. The truth is that those were organically grown. Pondicherry had overhead telephone, overhead electricity, and sewage was not even there, was an open drain. So once they decided to go underground, they simply opened whatever they could open and put the cables on top of each other. We are not going to do that because we have a planned city. So we can do it properly to have each service having its own unique sub-corridor. You don't want the guy from telephones to puncture a high-tension cable or vice versa. You don't want a water guy to puncture the electrical cable or vice versa. So this was an exercise which was done in 13-14 with all the infrastructure services of Auroville together. And we studied all sorts of standards from different countries, Australia, Western Europe, United States, and we came to a standard that we say, okay, this is the minimum we have to do to have clearance and to have reliable systems. In most cases, you can do it under the pavement. If you have a pedestrian pavement, if you take most of the West European countries, they have the carriageway, and they have, for pedestrians, they have, or cycles, they have on two sides these paver blocks, which in the country where I come from is just a 30 by 30 centimeter concrete slab, and you remove them when you want to change something, there's sand below, and you put it back. But it has to be a dedicated corridor. You don't want all this stuff to be thrown on top of each other in a very messy way. I was once in Churchgate in Bombay, and the road was open. And that also has organically grown. In Calcutta, they even started with DC first, direct current, and then it's a complete mess there. So let us not go in that direction. Let us plan it properly so that it also can be maintained properly. This is not what we are going to do, by the way, don't worry, but this is a typical one of those cross-sections that we studied from one of the countries, I don't remember which one, how each service has got a dedicated subcorridor, dedicated depth and dedicated width. And there are drawings, so when, for example, a contractor is called by the government to repair an LT cable, he knows exactly where to dig, and 90% chance that he actually will find that cable there. And there is a rule in some of these countries that if he doesn't find the cable there, but he finds it 10 centimeters to the left, he has to report that to the cadastre, where they will update then the data bank. So this is how it is typically done. Very often the stormwater drain or the sewage is even under the road, because there you never have to go back to. That's permanent. These are usually these big concrete pipes with manholes every so many meters. But all the other services will have to be accessible for repair, upgradation, replacement, etc., etc. Yeah, so the whole definition, the TDC releases the layouts, the Auroville service does the marking and clearing, and the infrastructure services install in the dedicated. I think this we have already covered in the separate presentation, so I don't want to repeat. You see the wind is also there, but in our case that is remote. And my last point is that if you want to be, a lot of people use this term smart grid. It's very fashionable. In our view, a smart grid, this is not a smart grid. This is the conventional grid where there is a one-way flow of energy from big power stations to millions of consumers. The smart grid is this, where there are multi-directional feeders. The highway is no longer a one-way highway, it is a network. And thank God that the electrical cables and wires are much more flexible than human beings. They don't care whether the electricity flows from left to right or right to left. So we're quite happy to, okay, you come this way, that way, no issue at all. You have to switch, some switch gear might have to be changed, some relays, but you can make the existing grid into this with not too much of intervention. This we have already covered. This is a typical grid-connected rooftop solar system. Energy storage we have covered already in the previous one. It's a very important ingredient. Smart grid we have already covered also. And I think this also we have covered, and then we thank you.
Hi, my name is Raj.
Yes, Raj.
I have seen some cross-sections where the service are heavily driving the design of the pathways or the roads, which we are about to design. So my question is, we are putting so much importance to these electrical, telephone, cable data. Just I want to come back. In my lifetime, I grew up in a gobar gas light. Not only just stove, gobar gas light, then I switched to, my family switched to electricity. Then now I'm on completely off the grid, which I live in a green belt. So my question is changing fast. So we are designing for the future and tomorrow. How relevant is it today? We're putting so much energy into designing these structures. They're all ultimately design our roads and so forth. So how important is that to concentrate on?
Yeah, you see, normally it should be done the other way around. As I explained a little bit earlier, normally you would have the DDPs ready, and then the infrastructure follows the DDPs. But quite frankly, Auroville failed to prepare DDPs. And at the same time, there were people living here who wanted water, electricity, and communication. So the infrastructure took the lead. We put the cart before the horse. And I hope that with this exercise, which is going to happen now, that the horse comes back in front of the cart. Now, whether you go for renewable energy, standalone or not, you need some services to be underground. What you normally should do is that you first make a calculation, what do I need for mobility? You don't talk about infrastructure, so what do I need for mobility? So do I need 2 lanes that makes maybe 6.6 meters width? Do I need a cycle path or not? And then you add it all up. And then you add the same thing, you do the same adding up for the services. Now, if the services are more than that width, then you have to sit, can we do something about it? Or you say, okay, then we go for the highest of the two. So unfortunately, what has happened, although Helmut presented this mobility study this morning, unfortunately, a lot of studies have never been converted into plans. They remain studies on a shelf in the office. So if now some of these studies with the help of the Vastushilp organization become actually plans, then henceforward the infrastructure services can work with those plans. Nobody likes to do infrastructure first and planning after. So, and by the way, the only thing that electrical service is doing right now is only laying the cable for the backbone which is needed for the town, whichever DDP comes. DDP cables, if I may call them, have not been installed. Because a DDP cable means, for example, if you go from the transformer into sector 1, we have no clue what that cable size has to be, unless the DDP is prepared. So all what is being done today on the crown and one radial only is what we call in our language the backbone, which irrespective of what the DDP is coming out, that backbone is needed. And in the case of the high tension cable, as I explained, only 50% of the backbone right now. So we do hope that the horse will come back in front of the cart, that it is led by DDP planning and not by infrastructure planning. On what basis, for example, will the electrical service decide that from the Vikas radial into sector 1 and 2, what size of cable they have to put? They have no clue. So when people put pressure, and some of the architects put pressure, Ponnusamy, I'm going to build a house there, I want a cable now. I don't care about the future. Then what will he do? Then he may put a cable which is 2 times of what is needed, so he can manage another 5 houses on the same cable. But that's not the way to plan. He should know in advance that that house is part of a cluster which is connected to feeder pillar number 22. Feeder pillar number 22 is connected to transformer 5. And then it is just a question of from the feeder pillar to lay a correct cable to that particular house. That is missing today. So I would request all the architects and planners, please put that horse back in front of the cart. We feel much more comfortable. And the standalone, if you have time, I will sit with you separately. I can't say I will convince you, but I will be able to tell you that if you get connected to a cluster like this, because you see, sometimes people in Auroville also are against the wrong thing. Don't be against cables or wires. Be against the electron that goes through it, which is maybe black or gray. But a wire or a cable is just connecting stuff. It's like you can't be against roads. You can be against the traffic on the road. So standalone has a lot of disadvantages. In fact, we did a study once of the Greenbelt standalone systems, the cost per kilowatt hour compared with the cluster system. It came 4 or 5 times, cost per kilowatt hour. So we will sit separately.
So a part of my question is already answered. It was about the DDP being there first and the infrastructure. How does that work? But what I see, you've answered that maybe the electrical service would not know the size of cable to do. But my question is also what I saw very relevant into your sections and your examples was what would come on top of the cables for it to be accessed easily. Would that also not be a part of the DDP which will help you find the exact location of the cables? So even right now when it talks about the backbone, isn't right now not having the DDP to even lay the backbone is also a constraint for you to not have the exact location and exact, the detail of what's going to come on top of where the the cable has been laid?
See, the backbone is being laid as of now along right-of-ways which are mentioned in the master plan itself. We call them master plan right-of-ways, which is the Crown and the Radials. No other cables are being laid except in some communities along paths. What the DDP will tell us, suppose they make a DDP of the residential zone, 5 sectors. In each sector there will be clusters. The DDP planners will tell us per cluster what is the expected load, expected consumption. And then they will also tell us how will people go, say, from the radial to that cluster, the paths and the internal roads and all that. Then the routing of the cable becomes that path, and the size of the cable becomes that load. See, cables, pipes always have to be laid along a path or a road so that you can always access them. It makes no sense to have the road here and the cable 20 meters further on in the bush. You have to be able to go there. In case of high-tension cables, you have to go there even with a big equipment and a big drum, etc. So accessibility for repair, maintenance, upgradation, replacement is a must. And that's why all over the world, these services are always laid on both sides of the mobility corridor. So if the DDP defines where the mobility corridor comes, the infrastructure has no choice but to go along that. So the routing gets decided by the mobility corridors, and the sizing gets decided by the loads. Same thing for water. Same thing for internet. Same thing for wastewater, everything.
It's the Dreamweavers first, Julia. Sorry, that's kind of difficult.
Toine, yeah, I have a question regarding, you had explained something the other day when we met last Monday, that you see the infrastructure corridor as something fixed on the Crown now I'm talking. That's fixed. But you said something that the road can move, but the infrastructure corridor has to be this perfect circle. Am I right in my understanding?
So what I have understood, we have received a cross-section drawing from the TDC. The last version was February 2020. February 2020 is the last version that the TDC distributed to the infrastructure services. Before that, they had a September 2016 version, and they had before that some 11 version. The last version shows a carriageway of 6.7, of which the center line is that famous 690 from the banyan tree, and that carriageway is a perfect circle. But the space on both sides of the 6.7 is not equal. On one side it is more, and on one side it is less. And one reason is that on one side there is a cycle path, and on the other side there is not. And on one side there are more services, so the services have gone below the cycle path. That is the reason. So if the TDC changes it, you see, look, for infrastructure it's very simple. It has to be accessible at any given time, and you have to be able to access it quickly. Like if the cable fails now, within 1 hour they have to be able to go inside and see what happened. So if the accessibility is there, the infrastructure services will not bother much.
Moreover, it has to be approved by the electrical inspectorate also. It has to be next to the road, obviously.
No,
it cannot be anywhere
clear.
else.
That's clear.
So that has to
but
be
my point was that what I've understood now after then you wouldn't have anything against if we all decide then from the infrastructure point of view, then if there is a slight bend there, right? If 30 meters or 20 meters or even 10, what we saw in Darkali today was it's just a few meters. That, because I've already laid the cable there,
yeah,
right?
I think that topic you should discuss when the overall this is a discussion on electricity. So I don't want to get into those details. I have a lot of personal views on it, which I will not share now.
Okay.
Because this meeting was meant for electricity and energy, but Toby is doing a session on the overall infrastructure, and then you can discuss that. You can also ask questions of, what happens if a 6.7 meter road is going to Meander? What happens to the mobility part of it? So let's not discuss that now.
I'm talking only about the cable.
The cable is always on both sides.
No,
not only the cable.
In Darkali, what has been laid was laid before 3-4 years, and now there's some change in the survey, and so it's not really where it's supposed to be. What we saw. So I'm saying that doesn't matter.
No, in fact, in several places. Another example is Tensi's place, right? There, when he was laying the cable, he was told, no, you don't put it here, you put it there. So there are some stretches, again, a lot of cost where what will have to be done is a new cable will have to be laid, and the old one has to be removed and used somewhere else. All extra. That's why I said, no, once and for all, you decide where the infrastructure comes and don't change it. Changing is extremely expensive. If a cable along the crown goes like this and there is a T-junction to a transformer, can you imagine what it means if you have to shift that cable and the whole transformer connection and the switch gear? It is just totally crazy. So we have been demanding from all the TDCs of the past, you can DDP forever, but freeze the infrastructure corridors, where they will come, how much will come, what size, that will be DDP dependent. In the same way with mobility, if you look at, for example, the same Narrow Street example, Narrow Street at one time was horse carts, then it was one-way traffic, two-way traffic, no traffic, but where the mobility takes place is always frozen. What type of mobility may evolve? I have lived in Pune for a few years. MG Road in Pune, while I was there, became in the weekends a pedestrian-only street. Two-way became one-way traffic. So what you cannot change, you see, once you fix a right-of-way and there's building on this side, on that side, you can't broaden the road, right? You can only make it narrower. So that is something you can't play with. All the rest you can play with. So our request from the infrastructure service for years has been, either prepare the DDPs and the DDPs include the infrastructure. If you are not doing that, at least decide where it will come. Because we have a population living here that wants electricity, water and internet 24/7. So it is basically, I would put that ball back in the court of the planners, quite frankly. I'm going to be very blunt. The infrastructure was more proactive than the planners, because the infrastructure said we have to stop this teeny story of individual connections, poles, spaghetti, etc. And the planners could not come to an agreement to plan. And I think now the Dreamweaving is trying to bring everybody together and take the plan forward. Get the horse in front of the cart. That's all I'm asking. And then the cart will go also in the right carriageway.
5 minutes. So we have Giulio and Omar.
No, it's all then you.
I guess my main question is not going to be answered, so I'll ask something else. Because I know that, Toine, you're talking always about clearing the right of way for all the radials and the ring road and everything. But what is your timeline for actually laying the HD cable under the radials and the outer ring road?
That depends on the DDPs. See, DDPs have a what factor and a when factor. So if the what is clear, it determines what has to be laid, and when the when factor is clear, it will tell when it is to be laid. That's called phasing. In the morning, when Srivatsa presented, he talked about phasing. And by the way, I would like to comment on one question which was asked, maybe by you, or by somebody else, about is implementation. Look, when you implement, suppose we say we want to add 5,000 beds, houses for 5,000 people. Then you need also educational facilities, health facilities, more collective cases. You cannot say, I put in the residential zone 5,000 houses. So all this has to be interconnected. So suppose we say 5,000 or 10,000, then the education people will say, we have calculated that with this 5,000 and this type of a demography, we need so many more schools. At that time, Ponnusamy cannot say, oh, sorry, I forgot to lay a backbone to the educational zone, so you have to wait 5 years. So you make a backbone also, so that when the zonal development takes place, that you don't have to reinvent the wheel then. Then you only have to connect in from the main backbone into the zones. That is the whole idea of a backbone. If Auroville didn't have the zones and if everything would be in one place, it would be a bit easier. But today you have to have zonal balancing. You have to have economic activities for 5,000 people. You have to have educational activities for 5,000 people. So the implementation question of this morning, I would have added to what Srivatsa said, has to be a balanced implementation.
I think there's just one time for one more. But Alan was in very, very early on with wanting to know you don't want to make that.
But this is the last one, no?
Yeah.
So it's okay.
And by the way, this right of way was not only by me. All the infrastructure services of Auroville have been asking for it. We have something like 25 letters signed by everyone, Chandresh, Luca, that please, please, please define this. Otherwise we get into a mess. There are still a lot of cables, by the way, in Auroville, and you have gone today on a crown walk, I will take you on another walk where there are storerooms, cycle sheds, houses on top of cables and pipes. You can never get there. We don't want that. And who's going to pay for all this? So you want to lay them straight away where they belong. That's all we're asking.
Yes. No, I'm actually agreeing with Toine on the issue of the horse has to come in front of the cart, and I feel like this is a good end for this because it shows it gives a sense of the duty on the shoulders of all the planners and the architects, because this is the mission of the moment, right? And because the issue of a right of way is quite complex. I wish it was as simple as infrastructure. It includes bioclimatic factors. You could make the wrong decision and you end up with much degrees higher in a city. It includes water issues, as we have seen with Julio today. It includes several systems connecting, and to work on this complexity, I don't even think only the architects. It has to be the architects with the engineers, because this is the integrative design process. And just we have to be careful while working on the ground, because we could cause problems, and at the same time feel the responsibility to quickly start getting something to convincing, so we avoid these problems in the future. Yeah.
Don't forget the social infrastructure. See, the physical infrastructure has to serve the social infrastructure. If you do not design the social infrastructure, the physical infrastructure starts having its own life on its own. Makes no sense. You know, I have been in meetings with Ponnusamy, Prasannaram, and Manikantan, where they asked me for advice that, look, we have an application from architect so-and-so to connect so-and-so building, and there is no DDP. What cable size do we put? So we make almost a wild guess. Well, it is probably in the next 5 years, so-and-so other buildings may come there, so let's go for 95 square mm. It's a totally illogical, irrational decision you take. So please get the DDPs on paper.